Alrighty, so this one's maybe a little bit tricky. First off, it's a definite integral, so we're going to have to plug in stuff at the end. But secondly, it's got arctan of 2x. First off, we have talked about how to integrate to tan inverse, but we haven't talked about what the integral of tan inverse is at all. I mean, like, if you think about it, we haven't, right? We've derived tan inverse, we've integrated into tan inverse, but we haven't integrated tan inverse. So, like, trying to integrate this thing might be kind of complicated because, well, we haven't really talked about it. The other thing I'm going to notice is that the derivative of tan inverse is always 1 over something plus something squared, right? And the derivative of this particular tan inverse is, there's no fraction right here, so it's just 1 over 1 plus this squared, and that's what this is right here. So you should see, at least now, that this thing's derivative shows up there. And this is kind of backwards from a lot of the u sub that we've done. A lot of the u sub that we've done so far, at least especially in this unit, it's like you look for something in the bottom and then you look for its derivative in the top. But this is really tan inverse's derivative times, you could imagine this having a 1 over this thing. So I'm multiplying it by, sorry, I've got tan inverse being multiplied by its derivative. So once you realize that, we say, oh, I'm going to let u equal the top of the fraction. U equal, I'm going to write tan inverse of 2x, because I like writing tan inverse better. I don't know, it just makes sense to me. Then that makes du equal to 1 over 1 plus 4x squared. So notice, and then actually, so it's not 1 over, it's 2 over. I have to do my favorite chain rule, because I got to do the derivative of that. Anyway, so notice that this does not show up. I don't have a 2 out front here, right? I just got a 1. I wonder if you can hear my dog barking downstairs. Anyway, I've got a 2 here. So I do not have a 2 here, but I do have 1 here. So I need this to match up with that, so I'm going to divide everything by 2. So 1/2 du equals 1 over 1 plus 4x squared. So what I want you to realize is that this fraction is nothing more than this being multiplied by that. I need you to soak that up. Say that again. This fraction is nothing more than this being multiplied by that. So what I'm going to do instead is just write this times that, because that's way easier to integrate. So this is equal to the integral, and I'll deal with my integrands in a moment, of 1/2 u du. That's it. So, now I need to take care of my integrands, my numbers at the top and bottom of my integral. This guy, I'm going to plug it, remember I'm going to plug them into u right here, right? So, I'll do my side work. U, 0 goes to tan inverse of 2 times 0 is just 0. Well, when is the slope on the unit circle equal to 0? Well, that would be 0 degrees, or 0 radians. So this actually stays as a 0. And then 1/2 goes to tan inverse of, well, it's 2 over 2. So that's tan inverse of 1. And I'm plugging it into that thing. By it, I mean I'm plugging this into that thing. And when is my slope 1? Well, that's at pi over 4. Clearly that's at pi over 4. Pi over 4. So I'm evaluating this from 0 to pi over 4. So, integral of 1/2 u du is, well, it's simple power rule, u squared. and then 1/2. That would be the 1/2 from the integration, and then the 1/2 from this, evaluated from 0 to pi over 4. So really, it's 1/4 u squared evaluated from 0 to pi over 4, which gives me, I only have to worry about this one. This one, when I plug it into this, gives me 0. So I just do 1/4 times pi over 4 squared, which is 1/4 times pi squared over 16, which is which is pi squared over 64. And that's the way it would show up on a multiple choice question, which is likely what this problem would be. So that's why I want to simplify it all the way down.